Hello, Justin.
Hello, how are you today?
Hey, I am doing great. I'm doing great. Now, we are going to introduce this talk. We're winging it just a bit because we have two speakers. We have Justin and we have Jill. Jill is going to join us momentarily after we sort out a few technology glitches, which is perfect for this topic, perhaps. I'm sure we can weave it in somewhere. So let me do a little intro. So hello, everybody. Welcome. Thank you so much for joining. I'm Wendy Zinger, Managing Director of Strategic Customer Programs at 𝐇𝐈 AI, and I'll be your host for this session at 𝐇𝐈 Conference. So good to have you all with us. A few things before we begin. Please do post your takeaways on LinkedIn or X and tag us. And the tag to use is hashtag #TestMuConf. So everybody in the community can follow this conversation. And also, if you have any questions during this session or after, please do drop them in the Q&A box and we'll take the questions towards the end of the session. So quick recap here. The next stage of Agentic AI will not be decided by who builds the smartest agent. It will be decided by which organizations get humans to work, decide, and lead with it. So plenty of agents pass every test, but they still get rejected by the people that are meant to use them. So the question here on the table that we will address with Justin and Jill's help is, once does the AI work is answered, how do you build the quality layer for can humans successfully work with it? We have two distinguished speakers, and I'm going to introduce Justin first since you're here, and hopefully Jill will be with us momentarily. Justin is a senior security and assurance engineer at Microsoft, specializing in vulnerability research, security automation, and AI-powered security workflows. As part of the Microsoft Security Response Center, he works at the intersection of software assurance, vulnerability management, and applied artificial intelligence. And I think, I'd love to have you talk just a bit about how you've helped security teams scaling their impact through automation, research, and data-driven decision-making, and streamlining that at enterprise scale. So this is Justin, and we've also got Jill, who shall join us shortly. Dr. Hosmer-Jolley is faculty at California State University, Monterey Bay, and executive educator, and she teaches at the intersection of AI, organizational behavior, leadership, and workforce transformation. Her research covers human-centered AI adoption, neurodiversity, and organizational readiness, and in particular, why technically successful AI initiatives struggle during implementation. And her message emphasizes that the future of AI will not be determined by technology alone. It will depend on how effectively humans learn to lead, adapt, and partner with intelligence systems. And I hope that is the perfect segue for you to get started, Justin. And thank you for presenting for us. And
absolutely, thank you for having me. I should be sharing my screen. Let me know when it's coming up. Can you see my screen yet?
I can't yet. Let's see. Present content or share your screen. Is that one button at the bottom?
Yep.
Let's see. I think it's happening.
Awesome.
Excellent.
All right. So thank you very much for having me. So today I want to begin our talk with the person who doesn't trust the agent yet. The person who might be responsible for a customer, a decision, a risk, or an outcome. Their skepticism isn't automatically resistance. It isn't a problem to manage away. Often it's a reasonable request. Show me the evidence. Help me understand what happened. Give me a safe way to disagree. Tell me who owns the result and when something goes wrong. The title of this talk names a tension many teams are starting to encounter. The agent passed every test and the humans still rejected it. Now what? The easy answer is to say, well, people need more training, more communication, or more time. And sometimes they do. But if we stop there, we may miss what their behavior is telling us about the system. Now, as engineers, we already test accuracy, grounding, reliability, security, privacy, safety. We ask whether the agent can complete the task, call the right tools, stay within policy, and recover from a technical failure. Those tests are essential. They're just not telling the whole production boundary. A technically sound agent can still fail as a deployed system if people can't inspect its work, challenge its decisions, control its actions, or carry responsibility with real authority. That is the gap we're calling the human quality layer. Adoption is therefore part of the quality outcome, not a separate change management score. If responsible people can't use the system with confidence, the deployed workflow hasn't succeeded, even when the agent's technical measures look strong. So today we're going to use 5 plain questions. Can I see it? Can I understand it? Can I influence? Can I own it? And can I trust it appropriately? We'll translate those questions into things teams can design, instrument, test, and release. This isn't about asking engineers to become organizational psychologists. It's about asking all of us to recognize that the complete system reaching production includes people, roles, workflows, leadership, and culture. So let's start with what failure looks like when the technology works, but the partnership doesn't. Human rejection is often quiet. People don't always file a complaint or refuse to use the tool. They keep using the old spreadsheet. They recheck every field. They ask a trusted colleague to verify the answer. Then they copy the answers of the agent's output into another system and rebuild the reasoning by hand. They use the agent for low-risk work, but avoid it when the consequences matter. And from a dashboard, this can look like adoption. A user signed in, a run completed, an output was accepted. From the user's seat, though, the workflow may now include the new process and the old process running side by side. That isn't irrational resistance. It may be the safest response available when the person can't see enough evidence or doesn't know how to recover. So imagine the model passes its evaluations. The orchestrator completes the happy path. Tools are authorized, security reviews close, latency is within budget, we ship. Activation rises, so the launch report looks healthy. But the real workflow gets slower. People verify every output because the evidence isn't visible. They abandon runs when the agent reaches an unfamiliar state. They create screenshots for their own audit trail because the product doesn't preserve one. They ask a manager to approve decisions the workflow says they already own. Those behaviors aren't noise around the system, they're system evidence. We should be measuring verification frequency, overrides, abandoned runs, duplicate work, time to detect an error, and time to recover. We should ask whether people can explain an outcome and whether they know that what the agent did on their behalf. We also need to notice the human impact. Duplicate work creates fatigue. Unclear ownership creates anxiety. A polished answer without inspectable evidence can make an expert feel that their judgment has been reduced by clicking approve. If a person remains accountable while their practical control shrinks, the workflow may be technically efficient and psychologically unsafe. Leadership changes what happens next. If leaders reward visible usage but ignore hidden verification work, teams learn to protect the metric instead of improving the workflow. And that rejection becomes useful design evidence. So before we diagnose the person, let's diagnose the condition the systems failed to provide. That gives us 2 lenses of one production. The 2 lenses are the human experience and the engineering response. I'm going to keep the human consequences visible because different roles need different proof. A legal reviewer might need citations, clear record of what policy languages were applied. A security engineer might need logs, diffs, tool results, and reproducibility. A business owner might need the likely impact, the clear decision, the reliable escalation path. And And the same agent can feel transparent to one role and opaque to another. Those differences can appear inside one team as well. The person making the decision, the person operating the process, and the person answering for the outcome may each need a different view. Designing for one of them doesn't automatically support the others. People also process information differently. One person wants a concise summary before deciding where to look deeper, and another needs the details, the sequence, the time to inspect them. One person is comfortable exploring an unfamiliar interface. Another is working under pressure and needs the critical state to be unmistakable. Human-centered design can't assume one ideal user with unlimited attention. So my lens is how we turn those needs into a buildable, testable system. Visibility becomes observability and provenance. Understanding becomes verification and defensibility. Disagreement becomes steerability and recovery. Ownership becomes approvals, escalation, decision rights, and audit. Trust becomes risk-tiered autonomy and calibrated reliance. That translation matters. If we leave a human need as a vague aspiration, be transparent, build trust, keep a human in the loop. It's hard to know whether we've delivered it. If we translate it into a state view, an evidence record, a reversible action, a named owner, or a release test, a team can work on it. These aren't competing perspectives. Human experience tells us what responsible participation requires. Engineering makes those conditions durable instead of depending on individual heroics. Together, they let us test both what the technology does and what a person needs in order to work with it responsibly. And that matters because an agent never arrives in an empty workflow. A workflow diagram shows steps, input, output, decision. A human system contains much more. It contains expertise, exceptions, informal safeguards, relationships, status, identity, communication habits, responsibility. People may have spent years learning which cases need extra care, which signals are misleading, and who to call when the standard path doesn't fit. Some of that knowledge is documented. A lot of it lives in practice. When we insert an agent, we don't just automate a box. We may move judgment, visibility, and power.
You want me to close Google Meet?
Sure. Welcome, Jill. An expert can quietly become an approver without anyone naming a role change. A coordinator can become an exception handler. A manager can remain accountable while losing access to the evidence needed to exercise judgment. A team member may wonder whether raising a concern will be seen as expertise or resistance to the strategy. And that's why workflow design for agents has to include the human contract. For every consequential step, name the actor, the authority boundary, the evidence required, the last reversible point, an escalation owner, and the state a human can actually observe. The architecture should distinguish between recommendation, approval, exception, execution, rollbacks. Permissions should be bound to the task, the environment, and the sensitivity of the data. Telemetry needs to let us reconstruct not only what the agent did, but what the human could see when deciding whether to intervene. Consider a hypothetical procurement agent. If it suggests 3 suppliers, that's one kind of action. If it drafts an order, that's another. If it submits the order, commits funds, notifies a supplier, the authority and recovery requirements change again. Calling all of those steps agent completed task hides the part people are accountable for. Workforce readiness is part of this contract too. Readiness is not just knowing where to click, it includes knowing the boundary of the role, recognizing uncertainty, practicing escalation, and understanding what judgment the person is still expected to provide. Now, communication matters before and after launch. People need a consistent account of what changed in their work, not just what features were added. Managers need to know what questions to invite. Teams need a way to revise the contract as the agents and the workflows evolve. The production system includes the human system it enters, and many organizations are discovering that AI can ship before that human system is ready. Jill, can you see the slide? Do you want to jump in and talk about these a little bit?
I'm sorry that I'm late to the show here. Little technical difficulty. I'm living up to the character of I have no idea what I'm doing technically. But Justin, I'm trying to catch up with you. So can you keep going for one more slide?
Sure. These numbers on the slide that we're talking about, they point to that uneven readiness that I was talking about. So 30% of people have implemented AI. 23% didn't know. And 13% reported that agents were deeply integrated, but only 1/3 understood how agents function. We should be careful about what these figures do and don't say. They don't say every implementation fails. And they don't say every employee needs to understand the internals of a model. They do show uneven, shared understanding of what has been implemented, how agents work, and where the responsibility sits. Now, if people don't know what a system can do, what it can't do, when it's acting, or whose authority it's using, trust becomes guesswork. Some people may overestimate the agent and accept too much. Others may underestimate it and duplicate work that no longer adds value. Both are readiness problems with operational consequences. So treat this as a requirements problem, not a communications footnote. Capabilities, boundaries, state, and ownership can only live in a launch email or a training deck. Put the task level boundaries in the experience. Connect evaluation evidence to real work scenarios. Let people practice success, ambiguity, and failure before the workflow becomes routine. Ask accountable users to predict what the agent will do in an edge case, what it will not do, and where it will ask you for help. If the user's mental model and the system's behavior diverge, that's a release risk. Training may be part of the risk, or part of the fix. So make clear, state, better labels, a different approval boundary, narrower permissions, or a redesigned workflow. But readiness is shared. People need preparation, and systems need to be prepared for the people. The data gives us enough reason to test that partnership directly rather than assuming adoption will follow deployment. It also reminds leaders not to confuse access with readiness. A license, a login, a completed training module doesn't prove that someone can recognize a boundary, evaluate a result, or respond safely when an agent behaves unexpectedly. So the human quality layer starts with 5 questions. Can I see it? Can I understand it? Can I influence? Can I own it? Can I trust it? The wording is intentionally plain. These are questions a person can ask while doing real work. They also give a cross-functional team a shared way to talk about quality without requiring everyone to use the same specialist vocabulary. Trust comes last on purpose. Trust can't be announced at launch, installed through a message from leadership, or inferred from activation. It grows through repeated experience in which the earlier conditions hold. I can see enough of the work. I can understand enough to make the decision. I can influence what happens. I have real authority and a clear path when something goes wrong. We use those 5 questions as a compact release framework. C maps to system state, evidence, provenance, action, history. Understand maps to explanations, verification, defensibility. Influence maps to steering, interruption, override, and important recovery. Own maps to decision rights, approvals, escalation, and audit, and trust maps to risk-adjusted reliance. This doesn't replace security, safety, privacy, reliability, accessibility, or model evaluations. It asks whether those qualities reach the accountable person in a form they can use during real work. A policy check that runs invisibly may protect the system, but a person may still need to know that it ran, what it covered, and importantly, what happens when it fails. The questions also create a better conversation than, do users trust the AI? The question invites a yes or no answer to something that is contextual and changeable. But these 5 questions help us locate that missing condition. They also help a team decide what to fix first. Over the next 5 slides, we're going to develop one clearly hypothetical example, an incident response agent supporting an operations team during a service disruption. It isn't evidence from a real deployment. It's a scenario we'll use to make each question concrete. We'll begin with seeing the work. The output, not the work. If I'm accountable for a consequential decision, I need orientation. What happened? What changed? What evidence was used? What tools acted? What remains uncertain? What's happening now? I don't want a raw log dump, 1,000 technical events that can be perfectly complete and practically useless in a moment of pressure. I want evidence that matters to the decision I'm responsible for, with a path to inspect more when I need it. So here's the first step in our clearly hypothetical incident response example. This is not real. This is purely hypothetical. An agent detects a sign of a service disruption and recommends rolling back in a recent configuration change. The recommendation says, likely configuration regression, rollback advised. That might be concise, but the incident commander still can't see the work. They need to know which alerts fired, which service or region are affected, when symptoms began, what changed shortly before the incident, and which dashboards and runbooks the agent read, and whether the agent has already taken action. They also need gaps made visible. Did one monitoring source fail? Is customer impact confirmed or inferred? And is the rollback target current? In this hypothetical incident, suppose the agent used a 5-minute deployment record, but a current error dashboard. The run view should show each source's freshness, so the person can judge whether a change may be missing. The view should also reveal a failed dependency query. That absence is part of the work. Without it, the recommendation can look more complete than the investigation was. Build a human-readable run record around 5 things: current state, evidence, action history, decision boundaries, and uncertainty. For this hypothetical agent, the current state might say that the investigation is active and no production changes have been made. The evidence view might connect the error spike and the deployment event, the configuration diff, and the relevant runbook. The action history might show that the agent queried monitoring, compared recent changes, and drafted a rollback plan. The boundary should show that the execution required the incident commander's approval. Uncertainty should state that the evidence is consistent with regression, but doesn't yet exclude an upstream dependency. Under that view, correlate events across planning, retrieval, the model, tools, approvals, and the downstream systems. Record source identity with freshness, tool targets, results, failures, and side effects. Preserve the detailed audit trail, but present a concise inspection view organized around the human decision. Visibility should also respect roles. The incident commander may need to make a decision summary about a blast radius. A service engineer may need the exact diff and query results. A communications lead may need the confirmed impact and approved language, not the infrastructure detail. Transparency isn't showing everyone everything. It's making relevant evidence available to the people who carry the consequences. Then test it with a person, not only with a schema. Give them a completed run and ask them to reconstruct the path. Can they identify the sources? Can they tell what the agent changed, what it only proposed, and what it failed to retrieve? Can it find the first point where the intervention was possible? And can it tell whether the evidence is fresh enough for this decision? So more explanation doesn't automatically create more understanding. A long answer can sound confident and still be impossible to verify. A short answer can be clear, but leave out the uncertainty that it should change a decision. The question isn't simply, can the system explain itself? The practical question is, does this help me make a better decision? For a person in a workflow, understanding is connected to an action. Accept, verify, edit, reject, escalate, or investigate. So let's continue our clearly hypothetical incident response agent. We can now see that it linked an error spike to a recent configuration change and drafted a rollback. But why should the incident commander believe that the configuration caused this disruption? A timeline alone doesn't establish that conclusion. The explanation should separate four things. First, the conclusion. The configuration change is the leading hypothesis. Second, the supporting evidence. Errors began after the change. Affected requests share a path controlled by that setting, and the observed pattern matches the rollback guidance in the runbook. Third, the uncertainty. An upstream dependency is also degraded, so causality isn't established. And fourth, the next verification step. Run a scope check or compare the unaffected region before authorizing the rollback. This structure is much more defensible than one fluent paragraph. Design the explanation around the decision the person must make. Prefer reproducible artifacts over claims of invisible reasoning. Show the configuration diff. Link the monitoring query. Preserve the tool return. Identify the runbook section and its version. Show the policy result that determines whether approval is required. If a test or a reasonable check can be rerun independently, make that possible. We shouldn't treat hidden reasoning as proof. The evidence available to the accountable person has to stand on its own, or people won't trust it. A concise rationale can connect the artifacts, but confidence in the wording is not confidence in the result. For a hypothetical incident, suppose two sources conflict. One dashboard suggests the rollback will reduce errors, while another shows the issues beginning before the configuration changed. The agent shouldn't smooth that conflict into a single confident answer. It should surface the disagreement, explain why it matters, and offer a way to investigate. In this hypothetical case, the commander might ask, what would make the rollback hypothesis weaker? The agent could point to errors in an unchanged region, an earlier onset, or a failed scoped rollback. Now the explanation supports changing course, not just agreeing. So test that directly. Ask reviewers to name the strongest alternative and the observation that would distinguish it. An explanation that only supports acceptance isn't supporting judgment. That behavior supports human judgment rather than competing with it. An experienced engineer may see that the second signal points to a different failure mode. A newer engineer may need the conflict highlighted so they know not to treat the recommendation as settled. So test explanations when the agent is right, ambiguous, or wrong. The wrong case matters most. A polished explanation can increase reliance on a bad result if the citations are irrelevant, the diff is stale, or the verification step doesn't test the actual claim. So when this goes wrong, who gets the call? Disagreement is part of a healthy collaboration. It isn't an exception to design around, and it isn't the proof that a person lacks trust. Often disagreement is exactly how expertise enters the system. If my only choices are approve everything or start over, the workflow hasn't preserved meaningful agency. I need to be able to change the goal, to add a constraint, to correct an assumption, or stop a consequential action. Back to our clearly hypothetical incident response agent, it recommends rolling back the entire configuration change across all regions. The incident commander agrees that that change is suspicious, but disagrees with the scope. They want to test the rollback in one affected region first, preserving traffic in a stable region, and pause customer communications until that impact is actually confirmed. A useful interface lets them express those constraints in the workflow. It shows the revised plan before execution. It makes clear which completed investigation steps can be reserved and which conclusions must be reevaluated before the scope changed. Engineer influence across the entire lifecycle. Before execution, confirm intent and constraints. The agent should distinguish investigate a rollback from perform a rollback. During planning, preview what it will read, create, change, send, or delete. At a risk boundary, require approval for the exact proposed action. During execution, let the person steer without discarding safe completed work. In our hypothetical example, the commander may reduce the target to one region after the plan is prepared. The system should create a new plan version, recheck permissions and impact, and preserve the evidence that is still valid. And after execution, support undo where true undo is possible, or a compensating action where it isn't. A configuration change might be reversible. A message sent to customers isn't. Recovery may require a correction and an escalation. The interface shouldn't use the same comforting words for both. The backend has to make the control real. That means independent tool calls, checkpoints, transaction identifiers, cancellation propagation, durable side effect records, and a known safe state. If an action crosses systems, cancellation must mean more than closing that dialogue. This is also where psychological safety becomes operational. People are more likely to raise a concern when disagreement is expected and recoverable. Leadership should frame intervention as responsible operation, and teams should let people practice it before a real emergency. Test the ugly moments. Simulate a network failure after a side effect. Trigger a duplicate retry. Use stale authorization. Can partial success across two tools introduce conflicting edits? Cancel that run while an external action is pending. For our hypothetical agent, suppose the scoped rollback succeeds when one service, but the monitoring tool times out before confirming recovery. The system should not claim the incident is resolved. It should show what changed, what remains unknown, whether retry is safe, and who now owns that decision. Add another hypothetical complication. While verification is pending, the agent drafts a recovery message. The commander should be able to hold it, keep monitoring, and prevent an unverified status from being sent. Separate controls matter. A single choice would couple recovery, verification, and communication. Good steerability preserves useful progress while constraining what has become unsafe. But influence is not unlimited freedom. A human can also be restrained by policy, expertise, or role. The goal is a clear, safe boundary where the right person can shape the action and understand the consequences. A stop button that only hides the progress indicator isn't control. An edit box that changes the words but not the executable plan isn't steering. The gate is whether a person can redirect, stop, and recover without losing the workflow. And control has to connect to real ownership, especially when the clock is running and the outcome has consequences. So this brings to how much trust do you want from me? If the agent acts, but my name stays on the outcome, I need real authority and information and time to exercise judgment. Otherwise, human in the loop can mean responsibility without control. That isn't trust. That's exposure. Ownership is more than placing an approval step before somewhere on the workflow. It means someone knows that a decision they own, what evidence they are expected to consider, what authority they have, and where responsibility moves when the situation exceeds their boundary. In our clearly hypothetical incident response scenario, the agent has prepared a one-region rollback. Who can authorize it? Who executes it? Who monitors the customer impact? And who decides whether to expand the rollback? Who contacts an external dependency? Who gets the call if the first action makes the incident worse? If the interface says only awaiting human approval, it has hidden the most important human question. Which human acting in which role has what authority? So encode accountability into the workflow. Distinguish the recommender, the approver, the executor, the monitor, and the escalation owner. One person may hold several roles on a team, but that system should distinguish those functions. Define which actions are advisory and which require approval, which require stronger approval, and which are absolutely prohibited. Bind those rules to a task, risk, data sensitivity, reversibility, and the blast radius. If our hypothetical agent, querying, monitoring may be allowed automatically, drafting a rollback plan may also be automatic. Changing one region may require the on-call incident commander. Changing all regions may require a second approver or an escalation to a service owner. And sending a customer notice may require a communications owner. These boundaries should be explicit before the incident, not negotiated through chat when the service is failing. Approval should authorize the exact proposed action for a limited time. A material plan change should invalidate it. Record the plan version, evidence snapshot, policy results, approvers, and final parameters. If the agent changes the target region, rollback version, or affected service after approval, it must ask again. These are fundamentals we've been dealing with for years as humans. So real ownership also includes capacity. A named owner who is unavailable, overloaded, or unable to really understand the evidence is not an effective control. The operating model needs coverage, escalation, and response expectations. Workforce readiness means people have practiced the role and know when they're allowed to say, this is outside my authority. That sentence matters. In some cultures, escalation is treated as a weakness or delay. Then the workflow may technically offer an escalation path that people don't feel safe using. Leadership behavior determines whether the path is real. So route escalations to a named role with a response expectation. Make the state visible while the workflow waits. Prevent the agent from quietly continuing with broader authority because an approver didn't respond. Now, in the hypothetical incident, the response crosses a shift change. A second commander now owns monitoring and any expansion. The handoff should carry the planned version, completed actions, unresolved uncertainty, and the transferred authority. An audit name isn't enough if the new owner can't reconstruct the decision. Ownership must be changing system state, not assumption from a calendar. So test your handoffs, your absences, your escalation timeouts alongside with the original approval. Audit the full decision. Oh, I lost my page. Did you guys? Can you still see my screen?
Yep. We see the three circles. Human, agent recommends, human. There we go.
Hi. Okay. I'm just gonna move on. Sorry, my screen is all messed up. So I don't want to trust every agent equally, and you shouldn't want me to. I may trust one system to summarize a low-risk document and still refuse to let it send a consequential message. I may trust an agent's data retrieval, but verify its recommendation. This isn't inconsistency. This is judgment. Trust should vary by the task, consequence, evidence, and experience. The goal is appropriate reliance, knowing when to delegate, verify, supervise, or refuse. Our clearly hypothetical incident response agent has now made its work visible. explained its recommendation, accepted a narrower plan, and operated within a named decision, how much autonomy should it receive next time? The answer shouldn't be more because the first incident ended well. Autonomy needs evidence across relevant conditions, including ambiguity and partial failure. So treat autonomy as a risk control, not a maturity badge. A useful progression is suggest, collaborate, act with approval, and act within bounded authority. At suggest, the agent offers a recommendation and evidence. At collaborate, it revises a plan with a person. With approval, it prepares an action but waits at a defined boundary. Under bounded autonomy, it acts only within narrow permissions, monitoring, and stop rules. Map every level to action, risk, and reversibility. Increase autonomy because the evidence supports it, not because a demonstration went well, because a competitor uses the word autonomous. Suppose hypothetically that our agent later produces false alarms after a monitoring pattern changes. The team can narrow the trigger, restore approval for that action, and explain the change without declaring the entire agent a failure. That is trust. Downward adjustment is part of the collaboration. Teams should know what pauses autonomy, who changes the boundary, and how current authority becomes visible. That boundary should remain visible and adjustable. People need to know what the agent may do on its own, what it will talk about, and what will stop it. They also need evidence that the boundary works under pressure. Watch both sides of reliance. Over-reliance may take an unverified acceptance on a high-risk task, rapid approval without opening the evidence or assuming that a fluent explanation means the underlying tool result is correct. Under-reliance may look at a repeated duplicate, checking on a task the agent performs consistently well, avoiding safe capabilities, or rebuilding every result manually. Under-reliance isn't just an attitude problem. It may point to missing evidence, previous failures that weren't addressed, or a role that still carries accountability without enough authority. We need to give people proof that their role needs citations, tests, diffs, reasonableness checks, policy results, and visible outcomes. Let them adjust oversight within policy. Make it easy to move autonomy down when the context changes, not up when the context grows. So trust is shaped by failure too. A system that acknowledges error, supports recovery, and visibility improves, gives people evidence for more accurate reliance. The release gate isn't users trust it. That's too broad and too easy to measure badly. The gate is reliance matches demonstrated capability and task risk. Our hypothetical agent doesn't need to become the incident manager. It needs to become a reliable member of the incident workflow with a role that expands only as the evidence earns it. So now we put all 5 questions back together as one human quality layer. So notice what happens what this framework doesn't require. Universal enthusiasm. It doesn't require every person to feel the same about AI. It doesn't define success as the absence of questions. People need enough visibility, understanding, agency, and ownership, and evidence to participate responsibly. Different people may reach appropriate trust in different ways. A person close to the work may need detailed artifacts. A leader may need assurance that boundaries escalate and that outcomes are being monitored. Both are part of the same system. The 5 questions are simple, but they aren't independent checkboxes. C becomes observability and provenance. Understand gives us defensibility and verification. Influence gives us steerability and recovery. Own gives us decision rights and escalation. And trust gives us calibrated reliance. So test those conditions as one workflow because they depend on one another. Observability without control lets people watch a failure. Explanation without ownership leaves informed people powerless. Approval without recovery makes every interruption expensive. And named ownership without psychological safety can produce an escalation path no one uses. Create the human quality layer scenarios alongside your model, your security, and your reliability evaluations. Name the accountable persona, the task risk, the expected evidence, and the intervention points. Then run success, ambiguity, and failure cases in a production-like environment. In the success case, can a person move efficiently without unnecessary friction? In an ambiguous case, does the system expose uncertainty and support an investigation? In a failure case, can the person detect the problem, stop further impact, recover, and escalate? And include human impact in the result. Did the workflow reduce or create duplicate work? Did the person understand their role? Did they feel able to challenge the agent? Did the design protect attention during a high-pressure moment? Did the experience strengthen capability, or did it turn expertise into a passive approval? Those questions belong in quality because they affect whether a system is used responsibly. A workflow that depends on silent vigilance is an exhausted person, isn't robust, even if every technical component is operating as designed. So use evidence from the review to create your release criteria. For example, the accountable user find the evidence used for the recommendation. A cancellation prevents unstarted side effects and reports any completed ones. A material change invalidates approval. A failed action routes to a named owner. Bounded autonomy stops when monitoring becomes unavailable. This shared language helps engineering, product, design, operations, governance, security, leaders, and accountable users to work on the same release boundary. It also makes trade-offs visible. A team can decide that a missing capability limits the launch scope or autonomy instead of pretending the gap doesn't exist. Miss one condition and adoption becomes fragile. People compensate in private. Leaders see incomplete signals, and the system loses the feedback it needs to improve. Which brings us to the environment around.
Hey, Justin, I'm gonna just quick, you guys, I'm just looking at the time, and we have loads of questions that people have put in the Q&A. So if you could wrap up in the next, 3 to 5 minutes or less, and then because I know people are excited to hear answers to some of their questions.
Absolutely.
Awesome.
Absolutely.
Thanks.
So let's figure out when the AI is wrong, because that's what people really want to talk about. The first visible failure teaches people more than the launch announcement. It shows that the organization really values when confidence meets reality. If someone changes the agent and gets labeled as obstructive, everyone learns to stay quiet. If a person reports a bad output and the first response is, well, did you use it correctly? They learn that speaking up carries a cost. If failures are hidden to protect the project, people learn to build private workarounds. Those workarounds may reduce immediate risk, but they fragment the system. Official metrics can look clean while real controls live in spreadsheets, messages, and individual memory. So psychological safety here, which is really the core of what we're talking about, doesn't mean removing accountability or avoiding those hard questions. It means that people can surface uncertainty, mistakes, and disagreement without being punished for protecting the outcome. Leaders have to model correction, not just success. They can. So the people closest to the work may see failure modes before a dashboard does. We want to give them the language, the channels, the authority to report what they see. The second response closes the loop. People keep reporting when concerns visibly become tests, boundaries, or workflow changes. So in that post-incident review, examine that agent's behavior, the information the person had, the available intervention points, and the organizational response. A production failure should create a new test. boundary, guardrail, explanation, recovery mechanism, or escalation path. So what can we do next week? We'll start by choosing a consequential workflow, not the entire organization. Choose a workflow where a person carries a real outcome. Bring in the people who carry the consequences. Don't begin by asking, do we trust it? Ask the people to show you how they work, how they verify a result. And listen for a workaround. I always copy this into a spreadsheet, or I take a spreadsheet before approving. That message, I message one person when confidence looks wrong. Look into those workarounds. Treat them as evidence before treating them as insufficiency. And I want you to prepare 3 scenarios: 1 success case, 1 ambiguous case, and 1 failure case. Use realistic task data when production-like environment within your normal controls. Then walk the 5 questions with evidence. If you facilitate a review as a demonstration, not a debate, you'll end up asking the accountable user to narrate what they believe is happening. And when they pause, ask, what are you looking for? What would you do next? Have people come to the table. It's a typical tabletop exercise. Rotate who answers the questions. End by naming what is safe to release and what must limit scope or autonomy. I want to go over these 5 questions really quickly because this is the important part. C, can the accountable user find the current state? Can they distinguish what the agent proposed? Understand, can they explain the conclusion, identify the supporting evidence, and choose what's next? Can they influence? Can they redirect the plan, add a constraint, or interrupt the consequential action? Can they own the process? Can they identify who recommends, approves, executes, and escalates? And then they trust. Does autonomy level match the task risk? Is it reversible? Can oversight move down when the conditions change? So log every no as a decision defect with severity and owner and exit criteria. The fix may be the user experience, the orchestration, the policy, incident response, or the operating model. But don't turn every gap into a tooltip. A stop action doesn't propagate an engineering defect. An exception with no owner is an operating model defect. And that brings us to the promise behind the human quality layer. I began with the person who doesn't trust the agent. The goal was never to talk about that person out of caution. Caution may be carrying expertise, accountability, or memory of a failure the team hasn't seen. The goal is to build enough evidence, agency, and accountability that caution can become informed reliance. It also means leaders can create a culture where raising a failure is treated as protection of the mission, not resistance to progress. Workforce readiness and technical readiness have to grow together. The human quality layer is not a software alternative to technical quality. It completes technical quality by including the human system where the agents actually operate. The future won't belong only to organizations that build the smartest agents. It will belong to organizations that build the strongest human and AI teams. Teams where each contributes to what it does well, where responsibility is clear, and where people can question, correct, and improve the system. Build the agent, build the workflow, build the human quality layer. Thank you.
Hey, thank you so much. And Jill, thank you as well, because this is your work together with Justin. And I think we had a little glitch towards the ends with the slides. So if you want to try maybe to display that last slide that had all those final thoughts on it, just so we can see that. And I'll hand you a couple of questions, and probably
Absolutely.
We've got time for just a few.
Absolutely.
All right, let's see. We have so many, and we really will not get to all of them, but perhaps you'll take some offline later. I'll see. So first of all, thanks so much, and huge audience today, and I'm delighted at the number of questions that came up. Yeah, I don't know, it's blinking in and out. I'm going to give you this one towards the end of the talk. What are humans rejecting that the test didn't catch? Trust, tone, or workflow fit? And that is from Swati Agarwal.
So trust is built on everything that we talked about. And so if you get to the root cause of that, why did I not trust it? Did I not trust it because I didn't see it? Did I not trust it because I don't understand it or it's not defensible? So I think that's part of the biggest piece. I'm trying to find the question.
Oh, yeah, it's like third from the bottom.
Oh, okay, cool. Oh, here we go. Trust in the workflow. So workflow fit is an interesting one because people build agents without knowing what the entire workflow is. People have an isolated silo of what their job is, of what they're doing, or what they're asked to do. And there's often nuance in that people don't understand. As an engineer, we ask for requirements docs, right? But someone who's putting together a requirements doc might not put tribal knowledge into that requirements doc. It might not put some connections that maybe aren't readily available. It might put assets that are turned off for 364 days a year into that workflow that all of a sudden are critical at the time of financial reporting. So the workflows have to be brought together with the people who are using it and the people who are building it, but they have to be built as an evolution. It has to be built together, and that's part of all of them, the trust and the workflow fit. The tone is an interesting one because people tend to reject tone if they see M dashes, if they see words that don't make sense, if they see commonly AI criteria, and that diminishes trust. But it doesn't diminish trust because of any real impactful change that's been made in their workflows. It diminishes trust because of the reputation it gets from it impacting other people's workflow. And that's the core of the issue. If it impacts someone else's workflow and they lose trust and they start telling people, I'm not going to use it because I don't trust it, that human to human interaction, that costs more than anything else. In marketing, we say the best marketing is word of mouth. Well, that's also the best way to kill adoption.
Fantastic. Thank you. We may have time for one more answer, but in case that runs long, I do want to remind folks, thank you, first of all, so much for coming. And again, thanks, Justin. Jill has dropped some tech glitch again, perhaps, but don't forget to check out the partner booths in the TestMu conference. Don't forget to post on social media TestMu, hashtag TestMuConf. And maybe we have time for one more question. So Justin, since you've already got eyes on the Q&A, I'm happy for you to pick the one that you think is most appropriate.
So I saw one in here that was really interesting. Have you ever had to kill a technically perfect agent because a human said no? Absolutely. Absolutely. I mean, it happens. The failure rate on that is quite significant because of the trust, because a lot of what AI does is black box. We ask it a question, we give it a data set, it returns an answer. But sometimes it doesn't tell us what the answer it returns was based off of, the logic that goes into that decision or that dashboard. And so now you've got a perfect agent that shows you an operational dashboard of every metric you absolutely want to see. It's got trending, it's got everything. The problem is you don't know what logic goes into it. So you've now got someone who can step up and say, I've got different numbers than you, and they can bring receipts. And you can bring an agent. And that's where a technically perfect agent gives you exactly what you want, exactly what you're looking for, but you can't defend that decision. And someone who's got an okay report with okay visualizations that tell an okay story have a stronger answer, and they'll actually be relied on more because their stuff is defensible.
Well, again, fantastic. Really, really interesting stuff to chew on and to act on. So I'm really, really grateful that you made it. I wish Jill could have been more integral part, but folks, thank you all so much for coming. Thank you for your comments. Apologize for all the great questions that have not been answered, but maybe we'll try, if we have a moment, to answer them offline. If not, the recording will be available and you may find some of the answers in that. So with that, any final words, Justin?
I appreciate you having us here. I think that we're in a state where we're all being asked to build more with less. And this is a critical piece, because we can all build agents, but if 90% of the agents we built don't get used, have we wasted all of that time?
Yeah. That's thank you. I won't follow that, but
Have a wonderful
100%.
day.
100%.
And enjoy the rest of the
Thank
conference.
you. Yeah, thanks everybody. Bye. So now we have to figure out how to get off this thing.